it's important to know these syllabus objectives so you know exactly what you need to know for your exam, right? So they require you, CSEC requires you to know how to solve log equations, to use logs to solve equations of the form a to the power of x is equal to b, and to apply logs to problems involving transformation of a given relationship to linear form. It's okay if you don't know or don't remember what any of this means. I will do it with you now. So we're on to the first objective. Before we start this topic, I need to make sure you know what exactly a log is. So the log of a number to a given base tells us the power to which the base must be raised to get that number. So just to show you what that would look like, if I have this example, log of 8 to the base 2 is equal to 3. Or some people might say log to base 2, 8 is equal to 3. It doesn't matter how you say it, just once you know how to write it, right? So you could say log 8 to base 2 is equal to 3, or you could say log to base 2, 8 is equal to 3. Just once you know how to write it. But what exactly does this mean? So by definition of a log, this means log of 8 to base 2 is equal to 3. This means that you must raise 2. So 2 here, this number is called my base. So you must raise 2 to the power of 3 to get 8. You must raise 2 to the power of 3 to get 8. And that's what log means. That's what finding the log of a number means, right? So you good with that so far?
Yes, miss.
If you're not good with that, just let me know and I will explain it again, right? So that's why you could say, okay, this is log form. Log of x is my number. So a base, I represent this as a, is equal to n, where n is just any number, right? And that's why I said, or that's why the rule says this, which is called log form, can also be rewritten like this. And we know that this is the exponential form. So a to the power of n would give me a number, and I could rewrite this in log form to get this. So let me just write it out. What does this mean? See, log of a number, so my number is x, to a base a is equal to n, or I can write this as a to the power of n is equal to x. They are equivalent. This is called the log form, and this is called the exponential form, right? So it's important for you to know the relationship between log form and the exponential form. So let's practice this now. Some examples. Express the following in log form. So I'll do the first one with you. Okay, so 8 squared. Oh gosh, no, that's not supposed to be equal to 60, it's supposed to be equal to 64. My bad. Okay, so 8 squared is equal to 64. And they want me to write this in log form. What I just told you is that log form is log of a number, so call that number x, to a base a is going to give me a number, right? And we said this means the same as if I raise this base, so I said a is the base, if I raise this to n, a number n is going to give me x, right? This is the log form, and I could rewrite this log form into the exponential form, and this is what it would look like, right? So 8 squared is equal to 64. That's in the exponential form. And what they want me to do is to write this in the log form. So all I have to do is look at these two and rewrite it in the log form. So I said A would be 8. So let me just write it to the side here. A is equal to 8. N, which is the power, would be equal to 2. And then X, which is the number, is 64 in this case. So looking at the log form, it says to write this in the log form, it's log of X. And we said that X is 64. So I'll put 64 here. It told me that the base comes down here. The base is 8. Is equal to N, which is, and notice how we go from the exponential form to log form. Everybody good with this so far?
Yes, Miss.
Okay. If you're not good with it, let me know, right? So now that I did the first one to you, I just want you to do the second one and the third one for me. Don't look at this one yet. I just want you to do number 2 and number 3. I'll give you 2 minutes to do that. Shouldn't take long. Just write it in the log form. This is exponential form. And you could tell that these are in exponential form. So what I want you to do is to write it in log form. And this is what log form looks like. So that shouldn't take too long.
Is log 10.
Wait, repeat. Log 10. Oh, wait. I put in the 10 down here or here?
10 down here.
So where I put in the 10? Putting it here? 10 is the base, or putting it here?
In the base.
Okay, in the base. If 10 going in the base, what number would come here?
100.
100. And what would this be equal to?
2.
Ooh, good job. So I have 10 squared is equal to 100. We know that is exponential form. And what does exponential form look like? It looks like a to the power of n is equal to x. That's how I was able to tell that 10 squared is equal to 100 is in the exponential form. Okay, we said that the exponential form and log form are related like this. So a is equal to n. This is my exponential form and this is my log form. If I want to write the exponential form into the log form, I just follow this, right? So 10 squared is equal to 100. I would say, okay, looking at this, 10 is a, is equal to 10. My n is the power, so that's 2, and would be equal to 2. And then x, which is the number, is 100. So now I could rewrite this into the log form. log form states that log of x, and x is 100, to the base, so it's 10 in this case, and this is equal to the number, n, which in this case is 2. And that is why this is correct. Any problems with this? No? Okay. Next one then. They gave me 3 cubed, and they said that this is equal to 27. We already know that 3 cubed is equal to 27. But this is the exponential form, and they want me to write it in the log form. So identify what my a, n, what's a, what's n, and what's x. So a in this case, hold on, I just need to write it out since it's a new topic that we're teaching. So a would be 3, because a is the base. N, which is the power, is also 3, so n is equal to 3. And then x, which is the number, is 27. So all I have to do is write this in the log form now. How do I write it in the log form? I just follow this. So log of x to the base a is going to give me n. We already established what a, n, and x are. So all I have to do is to sub in these values. So it's log of x, which is 27, a to the base a, and we said that's 3, is equal to n, which is also 3. Everybody good with this?
Yes, miss.
Okay. So this is not supposed to be 60, that's supposed to be 64. I'll change it. So next one. Find the following. Log of 25 to the base 5. Remember I said you don't have to say it like that. Some people say log to the base 525. Just once you know how to write it, right? That's most important. So can you do numbers 1 to 3 for me, please? I'll give you like 3 minutes to do that because it wouldn't take that long. And then I'll go through it with you. Following the same rules. They wanted you to write it in log form here, but now they want you to find the value. So let me show you what I mean by that. This is the log form of x to the power of a. Log of x to the base a is equal to n. What they did, they gave you this. So when they say, to find the following, what they really want you to do is to find n. Okay, so do that for me. Okay, could anybody tell me what was your value for n for the first one?
2.
2. So let's see if this is correct. So you tell me that n is equal to 2, right? So you tell me that this is equal to 2. So let's see if that's correct. Log form remember, it's like this. Log of x to the base a is going to give me n. What they wanted me to find here really was the value of n. We know that log form can also be written in the exponential form, right? They're related. That's what I'm trying to say. Log form and exponential form are related. If this is the log form, the exponential form looks like this. A to the power of n is going to give me x. In this case, this particular example, a, which is the base, is 5. So a is equal to 5. X, which is the number, is 25. So x is equal to 25. And we're trying to find what n is. Question mark. So let me just erase this so you don't get confused. They gave us this, and we're trying to find what n is, right? So we said, according to the rule, this could be rewritten in exponential form. How would it look in exponential form? It will look like this. So a, I said that's 5 to the power of n. We're trying to find what n is equal to x. And we said x is 25. You could just say, because you know that 5 squared is equal to 25, so it's just easy for you to say, okay, n is going to be 2. So you could really just eyeball that and say n is going to be 2, because we already know that 5 squared gives me 25. But if this was an actual question in the exam, you would be required to show all the steps. So instead of saying 5 to the power of n is equal to 25, so n is equal to 2, you would have to show, so I'm just erasing this, right? When we were doing exponentials, we said to solve exponentials, we need to write both sides to the same base. 5 to the power of n is equal to 25. 5 and 25, they're obviously not the same number. So both of these don't have the same base. So how do we write both of them to the same base now? I know that 5 to the power of n is equal to 25 could be rewritten as 5 squared. And now we can equate the indices. Remember, we did this when we were doing exponential equations. I have the same base now, so I can equate the indices. What do I mean by equate the indices? I just put n is equal to 2. So the answer, n is equal to 2. That's correct. So good job. Any questions?
So, Miss, you would have to show that working in an exam paper.
Yes.
Okay.
So instead of just stopping here and say, okay, 5 to the power of n is equal to 25, and we already know that 5 squared is equal to 25. No. You should write them to the same base first, and then show that n would be equal to 2. You'll get marks for writing them to the same base and then showing, and then equating their indices. So just remember that, right? You don't want to lose unnecessary marks. Next question. Log of 1 to the base 7. And they want me to find what this is equal to. So I'll just put n here. Can anybody tell me what answer they got?
Is it 0?
Okay, we have a 0. Let's see if that's correct. So log form, we know it could be rewritten. Okay. Okay, we know it could be rewritten in exponential form, like this. log form and the exponential form are related, right? So I would say that a is 7, x would be 1, and then n, well, that's a question mark. That's unknown. That's what we're trying to find right now. So a is 7. We're trying to find n, so I'll just go back the n is equal to 1. So my question is, 7 raised to what power is going to give me 1? And we know that when we were doing indices or exponentials, we know this law. Any number, well, any base raised to the power of 0 is going to give me 1. So I would say, okay, if this is 1, and I want to write them to the same base, I could say 7 to the power of n is equal to 7 to the power of 0. How did I get 7 to the power of 0? Because according to our law, any base raised to the power of 0 is going to give me 1, right? So now that I have the same bases, I could equate the indices. If I equate the indices, n is equal to 0. And that is why this is correct. Everybody good with this?
Yes.
Yes,
Okay.
miss.
Last one for this section here. So log of 127 to the base 3. And we're trying to find what this is equal to. So put equal to n. Can anybody tell me what value they got?
-3.
-3. Hold on now. So just now. -3. So let's see if you're correct. Log form. To write this in exponential form, it would be like this. It would look like this, right? A would be 3. If anybody doesn't understand how I got A to be 3, please let me know. A is 3, and we're trying to find n. So just go back, n is equal to the number x, which in this case is 1 on 27. 1 on 27. So maybe you might be able to look at this exponential and say, and already know the power, right? So yes, this would be correct. So just telling you now, it is right. So you might be able to look at this and say, okay, 3 raised to the power of -3 is going to give me 1 on 27. But like I said, you have to show all of your working because you don't want to lose unnecessary marks, right? We know a law that says from when we're doing indices, a to the power of -n is the same as saying 1 over a to the power of n. Remember, when we're solving exponential equations, we said we need to have the same bases, then and only then can we equate the indices, right? So obviously right now, these don't have the same base because I see a 3 here and I see 1 on 27 here. So what you should ask yourself is, how would I write both sides of the equation to the same base? Well, this is the answer. 3 to the power of n is equal to 27 is the same as saying 3 cubed. So I can rewrite it like this. But we still don't have the same base because I see 3 here and I see 1 on 3 to the power of 3. These are not the same bases, right? I see 3 and then I see a fraction here. That's not the same. How do we get the same bases? That's what we need to ask ourselves. So this is where this rule would apply. So I have 3 to the power of n is equal to, according to this rule, 1 on 3 cubed is the same as saying 3 to the power of -3. Now that I have the same bases, so I see 3 and 3 here, I can equate their indices. So therefore, n is equal to minus 3. Everybody good with this?
Yes, Miss.
Okay. If you're not good with it, let me know. So I'll count it down. 3, 2, 1. Okay. Can I clear off this now?
Yes, please.
All right. Great. So that's that part finished. Now we on to the laws or rules of logs. So these are some rules you need to know. You see surds, indices, and logs, they have specific rules that you need to know, right? So log of a to the base a is equal to 1. So when these numbers are the same, just like you see here, a and a, my answer will be 1. Log of 1 to the base a is going to give me 0. So let me do an example for that second one. Let me do an example for the first one too. So first one, log of a to the base a is equal to 1. So let me just show you a quick example of that. Say I have log of 5 to the base 5. This is going to give me 1. So maybe you're wondering, where did they get that law from? I don't understand. How is log of a to the base a equal to 1? Remember, it's not just about learning it off for learning it off sake, right? You need to understand why something works. So log of a to the base a is equal to 1. Say I didn't know this number here, right? I'm trying to find what this number is, just like we were doing just now. Remember, log form could be written in exponential form. So I could rewrite this as 5 to the power of n would give me 5. So how did they figure out that this is equal to 1? Remember, any number raised to the power of 1 is itself, right? So I could say 5 is the same as 5 raised to the power of 1. Now that I have the same basis, I can equate their indices, and that is how they got n is equal to 1. That's why the rule states, if these two numbers are the same, my answer is going to be 1. So I'm going to stop this meeting and then rejoin because we have less than a minute.